Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be looking at how to find the domain of a composite function. Alright, so let's get started. Keep in mind the idea of input-output of a function. Okay, so suppose that h of x, the function h of x, is x squared minus 9. And the function f of x is square root of x. The question we are asking is, what is the domain of the composite function h of f of x? So if you remember how composite functions work, it has an outside function, which in this case is h, and the inside function, which is f, right? So first, we will start with an input x. And the input x will be inserted into the function f of x. So we have to pay attention to the domain of f of x. So we are going to get a set of output f of x, which is what we call the domain, the range of f of x. And what we're going to do is we're going to take that range and insert that as input to the function h, right? And that is how composite functions work here. Now, the question we want to consider at this point is, well, if I started out with a specific domain of x, and I am putting that into the function f, I am getting a specific set of numbers that is called the range. Will all of those fit into the function h, meaning what is the domain of h and how will that map in with the range of f? So pictures is worth 1,000 words, right? So here we go. We're going to start with the x value, and since f of x is the square root of x as it is defined, we can only take values that are 0 or higher. And then we insert that into the function f. We get a set of outputs, or we would say the range would be square root of x value, which has to be also 0 or higher. We are going to now insert that into the function h. Can all of those values there fit into the function h? Well, let's see what h will take. H of x is square root of is x squared minus 9. It has no restrictions because the domain is all real numbers. So h of x will take in all real numbers, which, hey, all fit, no further restriction. That's great. So the domain of the composite function is just going to be what we started out with, 0 to infinity. Okay, so pause and digest that information before you move on. Now, what we're going to do is go ahead and take a look at that one more time, but just using pictures. We are starting with the function f of x equals square root of x, where the domain is 0 to infinity and the range is 0 to infinity as seen in this picture here. Now we're going to take that range and we are going to see if it is going to map into the domain of the function h of x equal to x squared minus 9. And the domain there is all real numbers because it's a parabola, right? So no further restrictions, which mean we can have a domain of our composite function to be what we started, which is 0 to infinity. So that is another way of looking at composite function using graphs. Now, what happened if we switch the order? What is the domain of f of h of x? Pause. Try this on your own before you watch this part of the video. All right, here we go. We are going to start with x, which would be inserted into the function h. So it will take all real numbers. In other words, the domain of h is all real numbers. And we are going to insert that into h of x. And since it's x squared minus 9, what we will get out would be negative 9 and higher. All of those values, negative 9 or higher, would be the range of h. And then again, we are going to ask ourselves, will that fit into my outside function? Well, let's take a look. F of x is the square root of x, and square root of x will only take 0 or higher. So obviously, we can see these two sets do not match up. And negative 9 to infinity is actually a larger set than 0 to infinity. So we have to throw out some values. Okay, so what values would we throw out? We throw out anything that is below 0. Okay, so what we mean by that is the range, okay, of h, meaning what we get out. And what do we get out? X squared minus 9, going to have to match up with the domain of f, which is 0 or higher. So x squared minus 9 is going to have to be 0 or higher. Well, let's take a look. X squared minus 9 looks like that. So at negative 3 and 3, we will have the zeros there. Okay, that's when x squared minus 9 is equal to 0. Anything to the left of negative 3 and anything to the right of 3 will give us values greater than 0. So in other words, even though we started out with all real numbers, we need to make sure that these two sets match up. And in order to do that, we have to throw out these values here. So the domain of the composite function f of h of x is going to just be negative infinity to 3, negative 3 actually, including negative 3, and then 3 to infinity. Okay, and that is how we find domain of a composite function. We do need to consider input, output, and the sequential sets. Up next, we will look at symmetry and even and odd functions.